So hopefully you have become familiar with good manufacturing practices, GMP, good laboratory practices, GLP, and a little bit about what goes on in a laboratory environment as far as methodology goes. How can we implement a new method into the lab, and then how can we perform those tests and give them to a client that has maybe submitted a sample for me to analyze. Well, this part of the module, it's going to concern math. Oh no, math! That's what many of you are probably thinking about right now. And some of this will get bad. I'm telling you now, some of this statistic, some of this mathematical concepts that we will be learning about, they're going to get rough. And with that said, I want you to fully understand that we are going to go back and we are going to be like Barefoot Contessa on Food Network, and we're going to go back to basics. Well, her basics is lobster. Our basics is not really learning how to take 2 plus 2, but we are going to go back and we're going to start off very fundamental because I don't want to assume anything. So we're going to go and we're going to talk about intro to calculations, and we're going to build up from that point on. Now, with that said, I want you to fully understand that even though we go through the statistics portion of this lecture module, you will probably not be faced with doing statistics by hand in a laboratory or laboratory-based company. A lot of times they will have an Excel spreadsheet or they will have a database that you simply enter or key in your result into. And this database or this Excel spreadsheet will automatically calculate the statistics that you need to report to maybe quality assurance, quality control, or put onto a report for a client. So a lot of this will be preset, predetermined, and it's done that for quality assurance and quality control purposes. I don't want to trust you to do the calculations. I want to trust you to enter numbers into a spreadsheet, and that spreadsheet has been double checked by many people to kind of make sure that these calculations are done the proper way. So that's really what goes on in a lab, but I think it's very important for you to understand some of the concepts that come behind some of the terminology and appreciate what the databases can do for you. So we've already seen one type of term in a couple of videos back in this lecture module, and this was the RSD, Relative Standard Deviation. And we're not going to start off talking about relative standard deviation. We're going to build up to that point, but this is a term that we're going to be talking about sooner or later. In order to get to that point, though, we've got to talk about a couple of basic fundamental concepts, and some of these you will already know, but again, I don't want to take it for granted. So if you do know them, just kind of stay on the edge of your seat, bear with us until we get through some of these developmental concepts. Right. So there's going to be a couple of theories in the laboratory that you need to take away. And first and foremost, what you need to understand is that nobody is perfect. Sorry, I hate to burst your bubble. Nobody is perfect. You're not perfect in the laboratory. The laboratory technician's not perfect. I'm not perfect. Your boss is not perfect. Try telling him that, though. The company's not perfect. The laboratory manager's not perfect. The PhDs in research and development are not perfect. No one is perfect in the laboratory. And for that reason, not only is no one perfect, but no measurement is perfect. Sorry. There is error all over the place. Yeah, error. Nobody wants to hear that term, right? Error. That's bad. Well, it's bad when it happens in a laboratory too. But we know that it's going to happen. There's no way around it. It's going to be there. No matter what you do, no matter how many years of experience that you have in a laboratory, you will never be perfect. And that is a trait that you just need to accept. You're not going to be perfect. You're not going to get 100% yields. Your melting points are not going to be identical. Your infrareds or your spectrums or your chromatograms later on in the program, they are not going to be perfect. They are not going to be textbook. So don't you dare strive to be that perfect, because it's not going to happen. You're wasting your time. So when you submit a melting point that's a couple of degrees off, don't feel bad about it. It's normal. I expect it. If it is spot on, I actually have more questions at that point. Did you lie about your melting point? Because it can't be that spot on. Did you do this melting point more than once? Because if you didn't, this is probably just a coincidence. Sorry, you're not that perfect. Those are the types of questions that I would ask, and those are the types of questions that your supervisors would ask as well. So please don't strive for perfection. I know that's kind of strange for you to hear, and I know that's going to be uncomfortable for some of you, especially those high achievers that want everything to be perfect, but it's not going to happen. So no measurement at all is going to be perfect in the laboratory. There's two things that the laboratory will look for from you. When you go into the lab, they will look for, number one, what we call precision, and number two, what we call accuracy. These two terms are completely different, and these two terms we have learned about in our CTC 111 class. And if you've not taken the 111 yet, don't worry, you'll get to that point. You'll be ahead of the class at that time. But we look for precision and we look for accuracy. We know that you probably aren't going to be 100% accurate. Your numbers are going to be off, because we know you're not perfect and no lab measurement's perfect. Your precision, though, this is something that we strongly take a look at as well, because the precision tells us how close your numbers are together. If I give you 3 samples, and I tell you to go test those 3 samples, and they're the same sample, how close are those numbers together when you do your test? If you're out playing a game of cornhole, and you throw that bing bag, or that corn bag, I guess is how it got its name, onto that wooden board, and you get that shot, you put it into the hole. Well, if you did that once, it's great. Can you do it with your second, third, and fourth bag? That's what precision's all about. Doing it once, you're lucky. Doing it twice, it's a coincidence. Doing it 3 times, now you're on to something. Okay, so precision and accuracy. Let's define these two terms. Accuracy is how close you are to the true value. That's what accuracy means. So I have this sample. I know what the concentration's supposed to be. When I do my test, how close is it to that number? That's accuracy. Precision. Precision is repeats. You're going to see this definition of precision in the PowerPoint file. And precision is going to basically be stated as the closeness of a measurement to other measurements of the same phenomenon. All that's basically saying is that you can repeat your numbers. You can do the sample once, get a number. Do the sample again, get the same number. Do the sample again, get the same number. That is precision. We look at precision and we look at accuracy both in the laboratory environment. So when you look at the PowerPoint file, Look at these two definitions. They will be worded a little differently, but for the most part, this is what we're trying to convey. Accuracy is how close are you to the accepted number. Precision is can you repeat your result over and over and over. Okay, so with that said, that's where this video is going to stop. In the next video, we're going to pick up this idea of error again, right? This is an important word that we're going to learn how to treat. We know it's going to happen. We know how to fix it. So, in the next video, we'll take a look at errors, the different types of errors, and maybe a little bit of how to fix the errors along the way. So stay tuned. We're not yet finished with the statistics. We're a long way away from being finished with the statistics.